So I'm going to talk about your test. Some students asked me about that. Yes, your test will be on March 3rd, the Wednesday. It will be covered chapter 1, 2, 3, 5, and 6. So we finish chapter 3, we will start chapter 5 today, and then chapter 6. The review is already posted in D2L. So if you look at the review of, I think either I posted it or I sent it to you guys. So if you go to the D2L here, you go under materials and you go under content. There is a review test here. So this is the review test 1 or review midterm. So if you click on it, this is the review test.
Will you post the chapter 6 videos as well?
Yes, I did. Yep, I did.
I don't see it on mine. I only see chapter 5 and 7.
I'll look at it and see. Yep, I'll double check. Should be there, but maybe it's. I'll otherwise I post it later today. So so this is the review, and you look at all these questions in the review. There are like around 18 questions in here. Some students ask me what is open-ended question. This is like open-ended question, like 13 and 14, where you have to show me the work, and like 15. These are all open-ended questions here, where it's not you have to write a lot of stuff. So all these questions actually comes from your notes. So if you go under the instructor notes in your go under instructor notes, you will find out that they all comes from there. So so like that big dollar sign, dollar bill that you see here, they all like this is one of them, and then the big dollar bill is the other one. So mostly, I can tell you all the questions is in the test here, so make sure you guys go through this, okay? Because your homework, the notes has all the answers in there. Can you go over how to take the data from the school website and put it into StatCrunch? So I'm gonna go through that. So make sure you know how to download your data file and then extend it. So in order for you, so you open your StatCrunch. So this is how you import your data. It's very easy. Go to data, go to load from files on my computer. So this is how you upload the data files from your hard drive to StatCrunch. You go under data, go under load from file on my computer, and then you pick the file that you resave. So browse it, save under data, it should be under data. And the one that I have is a body data, right? So this is the body data that I'm calling you to do. And then you hit open. And then over here, the delimiters, make sure you select tab. So your data looks something like that. So make sure you browse and upload it. And then, so for the delimiters here, pick tab. So you look something like that. When you hit upload, you will get everything you see. So these are the 300 data that I want you to play with. You guys have any questions? How to upload your data into your StatCrunch? It's very easy. Go to data, go to load, go to from file, my computer, and then you browse it. And then you can pick any files you want, bears, but make sure that these delimiters, you have to change to tab. So you look something like that. If you put it in comma, it's all in one big, so you have to tap it. So they will be put in separate columns, and then you upload it. Questions? How you upload your data into your StatCrunch?
Yeah, I did. What I did was to go to our online assignment, and I click on StatCrunch, and it shows data from your textbook.
You can also, yep, you can also do it that way.
All right.
When you go to StatCrunch, they will say gradebook, no, StatCrunch, sorry. And then there is a data set from the textbook. You're correct. You can click on this one. And then you can use body data, the first one. So you click on it, and it also automatically import it to your stuff. So there are a few ways to do it. If you download everything into your hard drive, you just hit data load to the from file on my computer. But if you have it already in the StatCrunch, you can always go to the textbook. I'll show it to you again. So this is something you guys need to know. Okay, this is not important, not difficult. So I will show you again how you do. So make sure you go to StatCrunch, you hit data set from your textbook. And this data set is the one that I'm talking about. It's exactly the same. So, but you need to find for it. So last time is body data. I think, where is the bears one? The bears one is, so I will tell you which one. Cars is measurements, I think. Fast food. So I will tell you which one is the one that you need to use so that you have to figure out. I think foot and height is the one. Is the bears one? No, this is not the bears one. Maybe no, shoe size. So I will tell you which data set you use so you know in the task which one you use. The bear measurement, that's a bear one. The bear measurement is a bear. You guys all right here? All right. Anyone have any questions on homework 3.3 beside question 3? Okay.
It's just like the second part to it. So like letter B.
Yeah.
I just have trouble with that
which
part.
number? Which number?
So it's the same question. So 3.3 or 3.4, it's the same. So just like how to
But this
find,
this question?
Yes.
So if you do the standard deviation is exactly like a z-score. So the first one is asking for the difference. I think you guys know how to do the difference, right?
Yes, subtract it.
Subtract. So you just take 75.7, subtract 16.05, the mean, right? This is the first one that you do, so it's not that tough. You just subtract it. Calculator can do that. So 75.7 minus 16.05. So this is 59.65. Okay. If you want to find the difference of the standard deviation, what you do is you take this number 59.65 and you divide this with the standard deviation, which is 39.74. And this answer has to be positive. So if you want to do part B, you divide this with 39.74 and it is 1.5. So since it's a positive, so this is good, 1.5. Let's say if you put this answer and this answer is a negative 1.5 in your calculator, you have to take the absolute value of it. So it becomes 1.5. The z-score is the same thing as the part B, also 1.5. Okay. Now, if I did question number 4, you find out that in question number 4, if you do the same thing, the difference. So the difference this time for number 4 here is the difference between the low pulse rate 36 with its mean, which is 71. So if you take 36 subtracted by 71, so you get negative 35. Then in order for us to do the part B, which is the standard deviation, you have to divide this with the standard deviation, which is 21.2. So if you take this number divided by 21.2, which is the standard deviation, this came out to be negative 1.65 something something, but you have to take the absolute value of it. That means you cannot have a negative. So for this question, the answer will be just 1.65. And then, but for the z-score, you need to use that negative 1.65. So the difference between the standard deviation and z-score is the standard deviation is always measured in the positive. So that's why if you have a negative z-score, you just absolute value it. You guys okay here?
I have a question. How come on number 3 it didn't have to be negative, but on this one the z-score is negative?
This is question 4.
Yeah, I was just wondering why
Because your pulse rate is smaller than your mean. So if that is smaller than your mean, your answer is negative.
Okay.
If your number that you're doing is bigger than, like question 3, this 75.6 is bigger than 18.44 is positive.
Okay.
Don't forget z-score. What is the meaning of a z-score if you have a positive or negative? Z-score that is positive means what? Is above the mean. So the reason why this z-score is positive is because the number that you measure here is above your mean. But for this question number 4, your z-score is negative is because the number that you figure is below the mean. You got it?
Yes.
So that's the reason why that one is positive, one is negative. Anyone have any questions? Now, we're going to do a little bit left in 2.3 here. Now, we talk about outliers. So there are, if you want to figure out what formulas to memorize or what to write, the outliers is the one here. So in order for us to figure out outliers, there are few formulas you do. If a question gives you 5-number summary, then you have to figure out these fences, the lower and the upper fences. And any data falls outside these fences is considered outliers. And the formula is Q3 plus 1.5 times IQR and Q1 minus 1.5 times IQR. So IQR and QN and Q3 you can find using StatCrunch. So if you do StatCrunch on your, if you go under stats, under summary stat by column, the same thing you guys did. Let's say I do NAC, for example. So you will have Q1 and Q3 is here. Does anyone know what is IQR is? Anyone know what is IQR is?
Interquartile range.
And how do you find interquartile range? That's correct.
Is that the Q3 minus Q1?
Very good. So IQR is actually Q3 minus Q1. So if you have your data, your calculation done in your StatCrunch, you got Q3 and Q1, you just subtract these two numbers, 24 minus 16.5. And that is your IQR. And then after that, what you do here is you plug it inside this formula. So the formula says the upper fence is Q3 minus Q3 plus 1.5 IQR. And your lower fence in this case is Q1 minus 1.5 times IQR. So as you guys know, we need to find the IQR first. So you have to subtract that number. So 24 take away 16.5. This is all in your calculation. So your IQR in this case is 7.5. So this is 7.5 here. So now in order for us to find this upper, you take Q3, which is 24, plus 1.5 times 7.5. And then for the lower fence, you take Q1. Q1 is 16.5, which is also in your StatCrunch, plus 1.5 times 7.5. So you have to use your calculator to figure these numbers out. So anyone can figure this number out?
Is the upper one 34.5?
Times 35.25.
Yeah, that's what I got.
And the lower one? I think I told you guys you can use one cheat sheets during your test time, right? And all the formulas is actually is in 5.25. So
Oh.
any,
Sorry, I was gonna ask, are we able to type it up and print it out?
up to you what you want to do with that cheat sheet. You can type, you can write, you can do anything, but make sure it's one page. It doesn't matter with me.
I got 27.75 for
Oh,
16.
sorry, this is minus. Sorry, this is not plus.
Oh,
It's
okay.
minus. Sorry about that. So it's a formula. This is a formula. So make sure if your formula is wrong, then all this number is wrong. So so this is 35.25 and 5.25. So what you do here is, how do you know that it's an outlier? You just sort through it. So this is about the neck, right? This is the neck here. So so what you do here is you go under your data, you go sort, you hit neck, descending, small to big. Yep. And then you replace by. So what happens is your neck is getting from big to small. So the highest neck length is 31.5. And so if you look at your calculation, 35.25, 31.5. So this is good. So because 31.5 is inside this range, so it's not an outlier. And then you look at the smallest neck size that you have. The smallest neck size is 10. So if you look at 10, 10 is also inside this range. So in this case, we don't have any outliers. So no outliers, because your minimum and maximum is inside the range. Okay. So a lot of students ask me, what is this upper and lower fence is used for? This is used to figure out your box plot outlier. Remember last time when you do box plot, the outliers is the little dot that is outside the little the whiskers on the left and right. So they use this formula to figure out. So another way for us, in order for you not to calculate, is just draw the graph of box plot of the neck that we have. Make it as the horizontal, you can see it. So you can tell that this one has no outliers, which is the same conclusion we found out using this. There's no outliers. So so when you guys have a 5-number sum is given, make sure you use these two formulas. And yes, these are the formulas you need to memorize. Some of you are asking. So please, you don't memorize this, make sure you put inside that cheat sheet. Another way for us to figure out outliers is using the modified box plot. This is only happens when all the raw data is given to us, like what we did in the neck here. So we can figure out by easily. There's no outlier here. We can figure out weight. Let me see what happens to weight. I want to see weight has outlier.
I have a question about that graph actually.
Yep.
So on the MyLab, it shows that you can click modified box plot. But then for ours, does it just do it automatically?
On what?
On MyLab. So on MyLab, I on the video it said that he clicked, StatCrunch. He like specifically clicked modified box plot, but
yep. So if you use fences to identify outliers, that is for you have outliers. See that?
And that's the only difference between modified and like regular box plot, right?
And if you don't do it, then they just extend it longer. They don't show outliers. So this is called box plot.
For identifying in the homework, the extra homework, did you want us to just say what it is, like if it's a mean or quartile 1, quartile 3, like that?
I'm sorry, Linda, what you're saying again?
Sorry. Oh, sorry, my mic is bad. I asked for the extra homework. You asked us to interpret it. Did you want us to like label if it's Q1?
I will teach you how to interpret things now.
Okay.
Yep. So how do you interpret? This is very important also in your test. How do you interpret box plot? This is in your homework, right?
Yeah, I did my homework just guessing and
It's
writing.
fine. So don't guess now, because in your test, I will ask you to do the same thing. So when you interpret the box plot, you have to write C, V, D, O. These are the 4 things that you will interpret. C stands for center. V stands for variation. D stands for distribution. O stands for outliers. So Rachel and Linda, I need to mute you guys because someone. So these are the CVDO that we talk about. So it all depends on outliers. So like, do we have any outliers in this box plot?
Yes.
Yes.
No.
Okay.
Oh,
So if you have an outlier, then the center is going to be median. And the variation will be IQR. The reason why that you have to report the median and the IQR if you have outlier is because median and IQR, they're resistant to outliers. That means you have outliers, you need to worry about.
Now, what about distant? What about the D?
The distribution? What's the distribution here? Skew left, skew right, symmetry.
Can I resubmit my assignment?
Yes, you can. Skew what? Someone say something. Skew.
your left.
Where's your dot at? Left or right?
Oh, you're right.
You're right.
So this is skew right. Yep, this is skew right. Okay. If remember the neck one that we did. So if you draw a box plot for the net, so make sure you report those. If you do a dot plots for the neck one, where's my? It's about not dot plot. Hot. Sorry, wrong graph. Box plot, not dot plot. And you do the neck one. So can someone tell me what is going on with this box plot? Do we have any outlier here?
No.
No. So can you tell me what is, so if you have no outliers, then you will report the mean and your standard deviation. So can someone interpret this box plot? I can.
Is it like skewed in the middle since there's no?
Okay, so do we have any, you say there's no outlier here, right?
Yeah.
So you have to tell me the mean and the standard deviation. So how do you find mean and standard deviation?
20.
You go to stats, summary stats, and column. This is what you did in 3.1 and 3.2, right? Then you go to neck, the one that I want you to calculate, compute. What is
It
the
was
mean?
height, wasn't it?
What is
Yeah, it's height in the homework.
Yeah, I'm not doing the homework for you.
Yeah.
That is your homework. I'm not doing the homework for you. What's the mean here?
Do you want it to?
I mean, 20.5, like 3, like it.
20.56. Someone say
5, 6.
something.
I was just
Cecilia?
gonna say, do you want it to be like 2 decimal points then?
Yeah.
Okay.
And then the standard deviation is 5.64. Same thing in your test, 2 decimal place.
Yeah, but excuse me, there are some of the answers for in the homework that is just 1 decimal place. So are you expecting us to put a 0 at the end of our to make it?
I think in your homework I asked you for 2 decimal places.
Yeah, like what I'm saying, some of the answers are like in 1 decimal place.
Like if you got 13.5, it's 13.5.
Yeah.
You cannot do 2 decimal places. If you have 1, if you have 10, it's 10. If 13.5, 31.5, 31.5, we cannot round. But if you have a lot of decimals like this, you have to round it.
Okay.
So this is the mean and the standard deviation. What is the distribution?
Oh, so if it's just one decimal point, you don't want us to round it to the nearest whole number?
If I ask for 2 decimal place for everything has to be in 2 decimal place. So if the question is 1 decimal place, you still need to give me 1 decimal place. What is the, can you tell me what is the Q1 for this neck in 2 decimal place?
16.50.
Which is the same thing as
16.5.
16.5. Can you tell me what's a Q3 in 2 decimal place? 24. 24 is 24. You cannot do 2 decimal place in there. You know what I'm saying? So like all this with no, this is already in 1 or no decimal place, that is your answer. But the one with a lot of decimals, that is the one that you need to round.
I was a little confused. I wasn't sure. So some of them I just put 1.0. I don't know. You didn't say I needed.
I'm gonna, this is so simple. The only thing that you need to round is where you see what?
Okay.
A lot of decimals. If you don't see any decimals like this, just put it there.
Okay.
It's not that difficult. So can someone tell me what is the distribution in this? What is the distribution here? What's the distribution in the neck?
Is it skewed right?
Center.
No.
Center.
What distribution is this? Is that skew left? Is that skew right or symmetry?
It's symmetric.
Symmetric.
Yep, the distribution is symmetry. You do not need to use a ruler and measure. Oh, David, this is a bit longer than that, so it's skewed to right. No, for me, they are almost the same length, so it is symmetry in this case. Okay, Rachel, I'll mute you. So it's symmetry in this case. And do we have any outliers in this case?
No.
So there's no outlier. So this is how you interpret your box plots. This is how you do it in your test and in your homework. Okay. All right, so today we're gonna start at chapter 5. So yep, we need to move on here. So please do this and submit your homework to me. So what is in chapter 5 here? So chapter 5 is what we call as a discrete probability distribution. What is a probability distribution? A probability distribution is where you have a random variable x that has a numerical value for each outcomes. Now, when you ask for the discrete case, do you guys know what is a discrete variable is? Discrete variable? You learn it in chapter 1. We got continuous variables and we got discrete variable.
That's like whole numbers.
Yes, discrete variable is like a whole number. Can you give me an example of a discrete variable?
The number of trees on the yard.
Number of trees in yard. Yeah, that's correct. Number of trees in your yards. So always start with the number of. If you hear the word number of, that means your answer is either 0, 1, 2, 3, 4, 5. You cannot have decimals. Okay, so the number of is number of something, number of calculators, number of TV, number of things you have, you know. So when you hear the word number of, it's going to be discrete case. Can you give me another can you give me a continuous variable in this case?
Would it be like 5.25?
Example of a variable, we get 5.25.
The height of
The
everyone in the
height,
class.
yep. The height, what else?
Weight.
The weight. So that means that your answer here can be in decimals, like 5.25, someone mentioned that. And usually this one has unit, like milligrams and centimeter and inches. Number of trees, the only unit is number of threes. So you got 0, 3, 1, 3, 2 threes, and so on, right? But for continuous variable, usually you got that unit like centimeter, liter, meter, you know, all this, you know, units that you know. Why I'm very concentrate on this is because in chapter 5, we are doing discrete case. And then in chapter 6, we're going to do continuous case. So when you do in my test, I won't tell you this is discrete or continuous. This is chapter 5 of chapter 6. You have to read the question. So if you see number of, this is a number of TVs, number of calculators, number of cell phones that a household has, that means it is talking about chapter 5. If the question is talking about height, weight, test score, temperature, all these things that have, that you can measure and you have units, then we talk about in chapter 6. You guys with me here? So we're going to talk about chapter 5 in this case. So in chapter 5, we are talking about random variable. So a random variable usually is denoted by X, and this is usually is number of something. So let's say number of TVs. Can I get, I can get a data from you guys where X in this case is a random variable and the number of TV can be 0, 1, 2, 3. Let's say this classroom, one students have 6 TV in the house. That is the most TV that, let's say Linda have 6 TV in the house and she's the only one, the highest TV they have. And then next we have is the probability distribution. What is a probability distribution is a table that have the random variable X and its probability, so PX. So how do we find this probability? If I collect data from you guys, that is easy. So if I ask you guys, how many of you guys have no TV at home? Let's say I got 3 students raise their hand, say I have no TV at home. How many of you have 1 TV at home? Let's say 6 of you guys raise your hand. And 2 TV at home, 7 of you guys have raised your hand. 3, 4 students. No students have 4 TVs. No students have 5 TVs, but I got 1 students have 60. So let's say I ask this and you guys, I don't have time to do that, but you guys raise your hand. So how do we find the probability? It's easy. You just find the total and then take that number, divide by it. So the total in this case is 21. So in order for us to find the probability, this is 3 out of 21. For no TVs. For 1 TV, 6 out of 21. 7 out of 21, 4 out of 21. 0 out of 21 is still 0. 0 out of 21 is still 0, and then 1 out. So in order for us to make it as a probability, you just take that number over by its total. So that is the probability. So this whole thing is what we call probability distribution. Okay, probability distribution. Now, sometimes this probability that you find is very small. So take out your calculator and can you help me to divide what is 1 out of 21? Go ahead and use your calculator and divide what is 1 out of 21. Please pay attention here because this is very important. You got this.
0.04. Okay,
this is okay. Let's do 1 out of, I want you guys to take a calculator and do 1 out of 2021. This year, 200. Take 1 divided by 2021 and see what you get. You guys got this in your calculator?
Yes.
Is that what you guys got here? Now, if you got this in your calculator, do you guys know what is this mean?
That's scientific notation.
Scientific notation. Can someone tell me what is this in decimals?
0.00049.
How many zeros here?
There's 3.
30, very good. And then 494 something, right? 495, right? Something like that. You guys with me here? Okay. Now, this number is super small, right? So what do we do here is instead of writing this, I just put 0 plus. So what is 0 plus? A 0 plus means that it is a positive probability, but that is considered very close to 0, but it's not 0. That means it's so small. Example, if I say 0 plus, it's like chances. What's the probability of you getting the jackpot? In the lottery, I will say 0 plus. 0 plus means it is possible to happen, but the chances of it happening is very slim. You guys okay here? So we use 0 plus here. So we talk about discrete and continuous, like what we just mentioned. Discrete has a number of, continuous is height and weight with decimals. What is the requirement for probability distribution? The first requirement is every x numbers you give me, it has correspond with its probability. So this is the first requirement, is every x here has its own probability. You cannot have one that is 7 and you don't have its probability. That's no good. Okay, so that's first requirement. The second requirement that you have is the summation of the probability has to be equal to 1. So what happened is that you take all this probability, and if you add every one of this, your summation has to become out exactly 1. And the third thing is each probability has to be 0 between 0 and 1. So if you look at this probability, this number 3 out of 21 is between 0 and 1, which is true. This number is between 0 and 1. And then you do the same thing, 6 out of 21. This number is also between 0 and 1. Same thing with 7 out of 21. So you find out that every single probability that you have here, they are all in between 0 and 1. So if you have those 3 requirements fulfilled, then this is called probability distribution. Okay. What is the useful of probability distribution is we can find the mean and the standard deviation. The mean is mu and the standard deviation is sigma. Now, I just want to point out again that the mean and the standard deviation that you use in chapter 5 is different than the mean and standard deviation you use in chapter 3. So in chapter 3, the mean that we use is x bar and the standard deviation we use is s. But in chapter 5, the mean is mu and the standard deviation is sigma. So do you know, this is starting to let you guys to know, the difference of a symbol. Do you know why this part we use S and X bar for mean and standard deviation, and why in chapter 5 we use mu and sigma? This is called mu, this is called sigma. Anyone know the difference?
No.
Mu and sigma?
Yep. And this is the reason why this chapter 3 we use X bar and S is because this is about sample.
Yes, samples and population.
And sample, we call this as a statistic. This is not from a sample. This is from what? Population. And we call it as a perimeter. So that's the difference between, so that means that if you talk about mean, we got 2 types of mean. Sample mean, population mean. Standard deviation, we got sample standard deviation and we got population standard deviation. And they are 2 different things because sample comes from the sample, population comes from population. So that's why the symbol we use also has to be different. So that's why we use X bar and S in chapter 3, mu and sigma in chapter 5. And how do you find this mu and sigma? You can either use this formula, which I can tell you that please don't use this formula. Do not use this formula. Okay, you'll be crying if you use this formula. Don't use formulas, but you use your StatCrunch. Okay, so how do you do your StatCrunch is you have to put your random variable x in var1, probability in var2, and then go to stat, calculator, and customs, values in, pick var1, and weight in, pick var2, and compute. So I just showed you how do I do it. So if you go to your, let's say you are doing this 0, 1, 2, 3, 4, 5, 6, and this is your probability. So how do you do this into your, how do you do this in your R is, I need a new one. Let me open up a new one. Where's my new? Oh, let's say I do var10 and var11. So so I just type 0. Oh my god, this is not good. I need a new one. Where is it? I need a new data table. There you go. Sorry about that. Just get a new one. So you have to write 0, 1, 2, 3, 4, 5, 6 in your var1. That is where you put 0 to 6 here. And then VAR2, you're going to put all this probability, 3 out of 21. What was the next one? 6 out of 21. 7 out of 21. So you have to type it out actually. 4 out, if you do your online homework, you can import it because you have that option. And then 0, 0. So this one is 0, 0, 1 out of 21. So this is how you're going to type. If it cannot be import, you have to type it in. And then what you need to do next is once you finish this, you have to go to, stat calculator custom. So you have to go to stat calculator custom. Okay. Stat calculator custom. And then the values in, you select var1, which is the 0 to 6. Weight ins, you select var2, which is all the probability, and then you hit compute. Something wrong here. What's happening? Maybe it's because it's not decimals. Yep, it should be compute, it should be come up. The other thing I found that might be a problem here is because it is not in decimal. So I need to change all this into decimal. So sorry about that. I need to change all this. Maybe because of it's not changed to decimal. Let me change the decimal. 0.143. So you have to put this in decimals then. 6 out of 21 is 0.286. So maybe, yeah, I think you had 7 out of 21. 0.333. You guys with me? I'll give you another example. If you do your online homework one, you can just export it immediately. This is 4 out of 21. 0.19. 0.19. This would be 0, 0, and then this is 1. So you actually have to change it to decimals. 0.048. So what you need to do next is, again, you go to stats, go to calculators, go to custom, var1 for the values, weight in var2, and you hit compute. You don't care about all this, you care about this. This is your mean, and this is your standard deviation. Okay, you don't care about the pictures and everything. This is the two things that you need to worry about. And this is how you find your mean and standard deviation, where you do not need to use your crazy formulas to calculate. Okay. If a question is asking for expected value is the same thing as finding the mean. Okay, so example is if I find the mean from using here, that mean is 1.81, so it's around 2. So even if let's say I don't need to ask you guys, I expected you guys have 2 TVs at home. Let's say this is a TV, right? This is 01 to 6 TV. So if let's say a new student came in, let's say his name is Josh, and I don't need to ask him, I will say, you know what? I think you have 2 TVs at home. And how do I know that? It's because the expected value is around 1.81. So expected means I'm expecting every student have around 1.81 TVs at home. So around 2 TVs at home. So that's what the expected value means in this case. So once you know the mean and standard deviation, you can use the range of rule of thumb. Remember range of rule of thumb? What's the formula for range of rule of thumb? Mean plus minus what? 2 times the
standard deviation.
Standard deviation. So we know the mean. The mean is 1 point something, and the standard deviation is 1.33. So you just take this plus minus 2 times of that, and you will get yourself the lower and the higher, and then to figure out outliers in this case. So I'm going to show you how to do chapter 5.1 homework because you can actually import it. So you don't need to type all the way. So chapter 5, so 5.1. So so this is asking us, you got the probability here. So this table in the right lists the probability of 3 births. What is the random variable again, random variable is always this. This is your random variable. So what is your random variable in this case?
X.
X, and what is X stands for here?
Girls.
Number of girls. So in this case, the random variable is not PX. So A and B is wrong. Your random variable is X, which is number of girls. The probability is 0, 1, 2, 3 because you got 3 girls, up to 3 girls. The value of the random variable is numerical. Yes, this is numerical. Numerical means number. So yes, the values of this is numerical. It's 0, 1, 2, 3. So it's pretty much straightforward type question here. So make sure you know the random variable is always X, in this case, number of girls. And then the value go from 0 to 3. And values are numerical. Next, 100 birth, exactly 57 girls is this probability. 57 or more girls is that probability. Is 57 girls in 100 birth significantly high? Which probability is relevant to use it? So when you talk about significantly high or significantly low, this is very important when you do your homework here. So when you do significantly high, you look for the probability of that number and more above. And if you look for significantly low, you look for the probability of that number that go less. And if this probability is less than or equals to 0.05, then your answer is yes, it is significantly high, or yes, it is significantly low. But if you have more than 0.05, then your answer is no. Okay, but what I want to point out to you is when you do significantly high, make sure it's that number and above. When you do a significantly low, it's that number and below. So when you ask for this kind of questions, there are 2 types of probability here. One is exactly, and one is that number and above. So which one is it that you want to figure out if you want to do the significantly high? The relative probability is exactly or above?
Above.
Yep, you need to go above. So every time when you ask for significantly high, make sure it's that number and above. And what is that? Is this probability is, what is this probability that's above? 0.097, right? 0.097. Is this 0.097 is less than 5% or more than 5%?
More.
It's more than 5%, right?
Yes.
So is it significant or it's not significant?
Significantly high.
Don't forget, if it's less than 5%, it is. If it's more than 5, it's not. So is it or it's not?
It is.
It is.
This number is, you say is what? More than 5%, right?
It's
More
not.
It's not. Okay. Again, let me repeat. If this number is less than 5%, then the answer is yes, it is. If it's more than 5%, it is not. Since this number is more than 5%, it is not significant because the probability is more than 5%. Okay. So make sure you guys know how to answer these kind of questions. It's very important. Next thing is figure out, are they continuous, are they discrete, or are they not a random? In order for us to have continuous, you can have decimals. So the number of light bulbs burned in this room. So can you have 1.5 light bulbs?
No.
So is this continuous or discrete?
Discrete.
Discrete. And another way you know is a discrete, the word, the number of. So every time when you see the word, the number of, automatically is discrete. Okay. How about the next one? The square footage of a house. Can it be decimal?
Continuous.
So it can be decimal, so it's continuous. How about the next one? Is the political party affiliation of adults in the United States? Do you know what is the political party affiliation in the of adults?
Continuous.
Well, you know what is this first? You know what is political party affiliation?
Yeah, the party you belong to.
Is that Democrat or is that Republican, right? Or the Green or something else, right? Independent.
So that
Right.
would be discrete, right?
This is not a random variable. So I want to point out to you guys is if your answer is not numerical, it's not 0, 1, 2, 3, 4, it's not decimal 2.5. This answer is either you are belongs to Democrat or belongs to Republican. Categorical variables where yes, no answers, gender, you know, all those, you know, that you don't have numerical numbers to represent, then it is not a random variable. You guys with me? How about the amount of rain? Can it be decimal? It's numbers, right? Can it be
Yeah.
decimal or can it be just 1, 2, 3, 4?
It can be decimals.
So discrete or continuous?
Continuous.
This is you guys all right here so far?
Yeah.
Yes.
The number of, what's the trick I told you when you hear the word the number of?
Discrete.
This is discrete.
Great.
So make sure you guys, this is not tough, okay? The time for you to fly from one city to another city, can you be decimal or can it be 1, 2, 3, 4 hours? Discrete or continuous here?
Continuous.
This is continuous. Time is always continuous. You guys all right here? Pretty much easy, right? Next, you want to figure out if this is a probability distribution. So how do you figure out its probability distribution? You have 3 requirements. The first requirement is every x has its own px. That is good because every x has its own px. Second thing is you have to add all your px out. So take out your calculator, add all these numbers out, and your total should came out to be 1. If you get 0.999 or 1.0001, it's still good. So take out your calculator and add all these numbers out. What do you get? You guys know how to add, right? And make sure you add correctly. What do you get when you add this probability up? Oh, sorry, that's 1, right? So my question to you is this a probability distribution? Yes or no?
Yes.
This is yes. As long as you add up this to become 1 and all of this is between 0 and 1, so your answer is yes in this case. So mostly what you guys need, and then you find the mean and the standard deviation. So how do you find the mean and standard deviation is you import this into StatCrunch. So you do not need to type. Remember last time I had to type this var1 and var2. So you do not need to type, you just put 0 is already import. So you go to stat, go to calculators, go to custom. Your values is always the 0 to the 0, 1, 2, 3, 4, 5. So it's in X in this case because they put X. And used to be var1. And then your weight used to be in var2 is in px, your probability, and you hit compute. Again, you don't need to look for everything. You just look at this. Your mean in this case is 2.5. And your standard deviation is this one, 1 point something in 1 decimal. So 1 decimal is 1.1. Now, what happens if this is not a random variable or not a probability distribution? If you answer no in question A, in the first part, then for mean and standard deviation, you just do part B. You just answer B because you cannot find a problem. This is not a probability distribution. So if this is not a probability distribution, you do not need to do all this work. You just say no for mean and no for standard deviation. You guys clear with me? You guys have any questions for me?
Can you repeat what you just said?
Okay, I want you guys to add all this number up.
It was equal to 1. Oh,
Does
sorry.
that equals to 1?
No, this is a different number.
But yeah, this is different number. You're gonna do it. Add all these numbers up. I also gonna take attendance, so please put present. Those are taking attendance, so please put present in your chat room.
It equals 1.
Yep. Okay. So if this is equal ones, then it's yes. Okay. So if it's equal ones, then it's yes. What happens if it's not equals to 1? Then you say the sum is not equals to 1. And then for part mean and standard deviation, you say you cannot find it. Again, you can. The reason why you cannot find it is because it's not a probability distribution. But since this is a probability distribution, so you will have to import this into your StatCrunch. And where do you go for the mean in this case? Go under stats.
Stat, calculator,
Calculator new.
custom,
And what do you put for values?
X,
X, and weights in
PX.
PX, and compute. And your mean is this one, 0.4. And the standard deviation is that one, 0 point something. Okay.
Yeah, so I have a question.
Mm-hmm.
In exam, is there a way we can use a StatCrunch to get this probability so you don't have to add all these numbers? Like to get it upfront?
You are using StatCrunch when you do in your test, yes.
Yeah, so on like how we have to add this 0.665, 277, and
Unfortunately, yes, you cannot import this to the StatCrunch like your homework. So you actually have to manually type it.
Okay.
You have to manually type this one. Okay. Same. So yep. So the homework here you can import to StatCrunch, right? But in your test you have to actually type it out. You have to manual type. So this is given us 10 birth. So this is the probability of it. And the question is asking for a range of rule of thumb. So in order for us to find the range of rule of thumb, you have to find the mean and the standard deviation. So again, you have to import this into StatCrunch. And you need to go to the stat, calculators, and custom. Again, this is your X and PX. And then when you hit compute, so this is your mean and this is your standard deviation. So can someone tell me how you figure out using the range of rule of thumb to figure out the maximum value? What formula should we use?
mean plus 2 times the standard deviation.
Very good. You use mean plus 2 times the standard deviation. And the mean in this case is, do not round this number. So make sure you use all your decimals, 5.017 plus 2 times your standard deviation, which is 1, and no rounding, please, 1.74. If you round, you probably get your answer wrong. Can someone use a calculator help me to figure out your part A, your maximum value in this case?
Is it 8.497?
8 point something?
497?
And this question was in 1 decimal place. 1 decimal place is 8 point what?
5.
8.5. And then they will ask you for the lower one, the minimum one. This is max. So the minimum one is exactly the same, but you do not use addition. You use what?
Subtraction.
Subtraction. So you use the same thing. And what you get in this case?
I got 8.5 for this one though.
Yeah, this is a max, 8.5. What's the minimum one?
Use the minus.
What you get? Anyone?
1.523.
So in 1 decimal place, this is 1.5.
Right.
Okay, good. And now you're asking, based on the result, is 1 girl in 10th significantly low? So that means that if you have your number of girls between these two numbers is no significant. If your number is less than this, it is low, significantly low. And if you have a number higher than that, it's significantly high. So my question is, they're asking for 1 girl. Can someone tell me, is this number 1 is inside or outside the range?
It's outside, so it's low.
So it's significantly low. So in this case, is 1 significantly low? The answer is yes. 1 is significantly low is because it is below the range. Okay, below, not above. You guys all right? So it's pretty much the same thing as what you did in, once you get the range rule of thumb, they will give you a number and figure out if that number is in or outside. If it's inside, it's not significant. If it's outside, either low or high, depends on the number. Questions?
So Debbie, this question is not concerning it. How do we import into StarCrunch? If it is in the test, how do we import that information?
You cannot
into
import. I already told you, you have to type it manually.
Okay, you open StarCrunch and type it manually?
Yep, like what I did last time over here. See, remember that I typed all this manually? Yep.
I couldn't open this. How do you, can you do it? Okay.
No, you cannot import. There's no way you can import a piece of paper into StatCrunch.
I know, but how do you
type it manually? Type it manually.
But how do you get a blank sheet of StarCrunch to type?
Goes to go to data, and then that it should be called load new data table. Data, load new data table. So this is blank. So if you click on this one, it's blank. Got it?
Can you say it one more time, please?
No, because
data,
if it goes, okay.
Load new data table. Please watch this again. This is important. And yes, you have to manually enter it in the test. There's no importing.
Data.
Okay. Data load new data table, and then you get a new one. And you can always use all the var here. You can use var 8, var 9, var 10. You can always add extra on it. All right. So
sorry to take you back. Like if we have the test question now, we've not opened our StarCrunch. When you go to StarCrunch, your page on the online assignment, and you click on StarCrunch, it doesn't take you to a blank data.
Yeah, it will give you to the blank one. Yes.
It doesn't. I've tried it.
How do you do it? You go to StatCrunch, right?
Yeah.
And then where do you click?
I clicked. So I'm not looking for data for my textbook. So I clicked StarCrunch website. It's wrong.
Yeah. And then open StatCrunch.
Okay.
And you get a blank one.
All right. Thank you.
Class, this is the 5th week. You have to practice this constantly. And I'm not showing this again. So make sure you guys do this like constantly. Make sure you guys know what you're doing. Especially I give you special homework. Do your special homework because that's in your test. And unfortunately, like if you do your online homework, you can open it in Stat, you can export everything in StatCrunch, but in your test, you have to manually type everything in.
Oh God, is it?
No, there's no other ways. There's no like if example is this question number 5. I'm asking you to find the mean and standard deviation for this. There's no way you can import this into StatCrunch. What you do? Let's say this is your test. So you have to
data load new data table, then type.
Very good. Yep, you're correct. And then you got this new data table, and then you have to put 0, 1, 2, 3, 4, 5, and then all the decimals here. No shortcut. Yep. And if you enter one of this number wrong, what happened?
Every other thing. Yes.
Everything is wrong. Yes. Okay. All right. Next, we'll talk about here.
Is it possible for, since you have all these things set up, this homework assignment and all of that, is it possible for us to like use this one that is already set up to do the exam, that we don't have to use paper? All you need is just you have the camera.
No.
and this online.
Your test has to be entered manually. You cannot. You guys can enter date numbers, right?
Because like all these things, we still use like papers to like solve to get the answers while doing the homework. That's what I'm asking.
Yeah, you have to use it. How do you do your math test?
I've never taken a math.
You haven't taken a math test before?
Yeah.
How do you do a math test? Can you do this without writing things?
No, you solve in a paper, then you pick the options, the answers.
So you will do the same thing. This is what you're gonna do. You look at my notes, right?
Yeah.
That is what I want you guys to do.
Okay.
Take out a piece of paper and start writing it out, and then that's where you have to scan. I will look at your chapter 3 test and chapter 3 homework and see what's going on. Okay, we're gonna continue here because this is all, you guys should know what to do here. It's not something that's difficult to write things on a piece of paper and then I will see your chapter 3 homework. You will see it. This question is given us this probability distribution. Can you tell me what is the probability getting exactly 6 girls in this case? What is the probability getting exactly 6 girls? So 6 is right here, right? And what is the probability of that?
0.111.
0.111. Can you tell me what is the probability getting 6 or more girls? So what you do with this? You add what?
0.003 and 0.001.
Do you include 6 or not include 6?
Yes.
Yes, because 6 or more means you include 6. So you have to add 0.111 with 0.03 and 0.001. So your answer is 0.115. So make sure you add 6 because it says 6 or more. So my question is, if I want you to figure out 6 is a significantly high, which one do you use? The answer in part A, the answer in part B. Remember last time when I asked you for significantly high, are we using answer in part A, which is exactly 6, or answer in part B, 6 or more?
B.
B, because significantly high is always answer that number or more. So that's why it is part B, because it is a probability of given of more, since a part of the given, yep. So it's part B, since it is a part of the given or more extreme result. Yeah, it's part B. Our answer is B in this case. And then now the question is, what is that? You say it's part B, right? So what is the probability you get in part B? 0.115, right? Is this probability less than 5% or more than 5%?
More.
So more than 5%. So is this considered significantly high?
Yes.
Less or
No.
more? More than
No.
5? The answer is no,
Yeah.
right? It's not.
No.
So the answer is this is not significantly high. It's because it is more than 5%. So it's not. So make sure you know how to answer this. It's very important. Questions?
Wait, you just said if it's more than 5%, it is significantly high, right?
It's not.
It's
If
not.
it's more than 5%, it's not significantly high. If it's less than 5%, it is significantly high or low. Doesn't matter, it's high or low. The 5% is the one we use. Questions?
So okay, I just want to so For the question, it's talking about girls, like the probability of having girls or X amount of girls.
Mm-hmm.
So if it's less than 5%, so if it's less
We'll do
than
another
5%,
example. We'll do another example.
Okay.
So this, because I don't do all your homework, I want you to do your homework. So what is the probability getting exactly one girl in this table?
0.012.
0.12?
0.012.
0.012. And what is the probability getting one or fewer girls in this case?
0.016.
1/6, because you add 12 and 4, right?
Mhm.
Okay. So the question now is asking, which one do you pick to figure out it is significantly low? A or B? A or B? Again, significantly low, you have to find what? That number or less. So which one you pick here? A or B? Exactly, or that number or less? A or B?
B.
B. So make sure you understand when they ask for significantly low, make sure it's that number or fewer. If it's significantly high, that number or higher. So it's going to be B, because I don't do the complement. Since getting 0 goes in an even lower number than getting 1, so the result, the B is the one that you're looking for. Okay, so I don't ask this question in the test usually. So now this is a number. So you say B, the chances of that is 0.016, right? Is 0.016 less than 5% or more than 5%? Which one is it?
Less.
So that means this is the one we're looking for, right? So is this significantly low? Yes or no?
No.
No.
What do I circle here? What do we say when okay, class, I circling this one, right? What do I say in that circle? Yes or no?
Yes.
Yes. So your answer is yes, it is significantly low. It's because it is less than 5%. That's why I circle this. That means it's yes. If I circle this, it means what? No. Okay, let me do one more time. If your probability came out to be 0.038, is this significantly low?
Yes.
Yes. Yes. Why?
This is less than 0.05.
Yes, you are correct, because this is less than 0.05. This is what I want you to do in the test. Now I give you another one, 0.087. Is this a significantly high?
Yes.
No. No,
No, because of what?
it's more than
This is
0.05.
more than 5%. Yes, that is correct. So I don't care about significantly high or low. You still look at the 5%, and that's what you're looking for. Okay. So this is how you do 5.1. So make sure you understand this is very important, the 5% here. So if you guys want to take a picture of this, be my guest. The 5% is always, we always use 5% because of the statistically significant that you learn in first chapter. So every time is the 5% is a magic number. Okay. So this is what we call as a probability distribution. So in 5.2, we will be talking about binomial distribution. So binomial distribution is also a discrete case, but you have to fulfill 4 things. The first thing about binomial distribution is it has to be, you have to have a fixed number of trials. What is meaning I say fixed number of trials? Fixed number of trials means n. So that means that if you give your, if you have your homework here, let's say, if you look at this, the last number 8 is the fixed number of trials. That means you got 8 births in this case. So if you look at this example, So 8, n is 8 in this case. So usually if you click on this, you got 10. That means you got 10 birth. So this 10 birth is your n. We call it a fixed number of trial. So usually you have it. So that means that you need to stop at one point. You cannot go all the way to infinity. So that is the first requirement. The second requirement is independent. What is independent means? Independent means that the first birth doesn't, the second birth doesn't depend on the first birth. So for example, when you have a baby, the first baby in this case is a girl. Is your second baby depends on the first baby's gender? Or totally opposite?
No.
It can be boy, it can be girl, right? Totally independent, right?
Yeah.
And let's say you got a boy on the second birth. The third birth, is that depends on the first two birth?
No.
No, so this is what we call independent. Independent means they doesn't depend on it. Okay, that is meaning of independent. And then it has to have two outcomes. So example is this, the one that we just talked about, boy and girl. So you got two outcomes. If you take a multiple choice question, either you get it correct or you get it wrong, two outcomes. Yes or no, two outcomes. So if any two outcomes, you can do it. But if you have more than two outcomes, yes, no, maybe, then you cannot use binomial. Okay. And the last thing about binomial is the probability is success is the same. Okay. What does that mean here? It means that what's the probability of you getting girl on the first birth? 50%. What's the probability of you getting boy on the second birth? It's also 50%, right?
Yeah.
And this is also 50%.
Yeah.
This is also 50%. Boy, girl, 50%, 50-50, no matter. So if you have a fifth, let's say you got all girls, 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 and girls, all 4 girls. What is the chances of you, the fifth one is a boy? High or low? Higher than 50% or lower than 50% or exactly 50%?
Exactly.
Exactly 50%. So a lot of students doesn't know this probability. You got 4 girls in a row. Oh, you say that this fifth one is definitely going to be a boy. No, the chances of you getting girl boy is on the fifth birth is still 50-50. So don't get cheated by it. A lot of students think that way. Okay. And that's where if you go gambling, you got gambling problems. So if you manage to, this is what the managed problem, because you beat black color, it came up red. And you beat red, it came up black. You do it 10 times in a row, you get wrong. And then the next time you say, I'm going to put everything in there. And it's still 50-50 chance. So that's the reason why I do not go gambling. Okay. So, so these are the 4 requirements. So if you fulfill all these 4 requirements, then you can do a binomial distribution. Okay. There is one called 5% guidelines of conversion. This is used when you select a sampling without replacement. For example, what is without replacement? I'll show it to you. When you have without replacement, what does that mean is it means that when you have a group of people, you pick one person out and that person does not go back to the pool. So this is without replacement. So let's say I got 30 students in this classroom, and I'll pick 2 students randomly to go out for dinner. I'll pay for it. So let's say I pick Cecilia, it's the first one. And her name she will not be going back to the pool because then she can pick again, right? So now I will pick another person. Let's say I pick Jana, example. So what happened is that this is a dependent case. The reason why this is a dependent case is because when I got 30 students, if I pick Cecilia out, these 30 students will become 29. So the chances of me picking another student is better because your size is getting smaller. From 30 students to 29 students, your size is getting smaller. So, and this person I pick depends on the first one. So if I pick Cecilia, I cannot pick Cecilia again, right? If I pick Jana, I cannot pick Jana again. So this is without replacement. So automatically without replacement is a dependent case. So what happens is, watch the YouTube, Teresa. We're almost done here. So what happened is because of the binomial, binomials need independent cases. So we have to use this. We can change this dependent to become independent if you divide n over n. And if this number is again less than 5%, less than or equals 5%, then we consider this as independent. So what do we do? Otherwise, it's not. So what do we do in this case is we pick 2 students. So I take 2 students out of 30 students I have. What is 2 out of 30? What percent is that? 2 out of 30 is 0.00.0666666. Is this number less than 5% or more than 5%?
More.
More than 5%. So that means it is dependent. So can we use binomial in this case? Can we use binomial in this case? Because
No.
binomial states it has to be independent. This is dependent, so we cannot use binomial. Okay, so so make sure, and what is the keyword that you're talking about when you talk about this 5%? The keyword is without replacement. Okay, so like the babies, the boy and the first one is boy, the second one is girl. That one is not without replacement, so you do not need to worry about calculating this 5%. Only without replacement is the one that you need to look for. Okay, and so what we have to do here is there are some notations. P stands for probability of success. Q is a probability of failure. So let's say that the probability of success of getting a girl is 50%. What's the probability of failure? That means not getting a girl. Is still 50%. That means that if you add these 2 up, you get exactly 1. Okay. Usually the question in your homework and test, they only give you the P, they don't give you a Q. For example, if I give you the probability is 0.2, 20%. Can someone tell me what is the probability failure in this case?
0.8.
0.8, yes, because add up, it becomes 1, okay, or 80%. So this is what we call as P, probability of success, Q, probability of failure. And in this case is a number of trials. As I mentioned, this is the last number. This is your N. Okay, remember you got X, 0, something, something. It always start at 0. The last number here is your N. We call it as number of trials. And X in this case is the number of success. So what is X? X is all this. This is X. So your X can be 0. Your X can be 1, 2, 3, 4, 5, up to 8. Okay, that is X. And then when I ask for PX, PX is the probability of getting X. Remember last time when you do your homework of the one that we just did just now on here, I asked you what is the probability of getting 6 girls, 0.111, right? So that is the meaning. So if I want to find P6, P6 is 0.11111. So that is the probability of getting 6 girls. Okay, so that is a symbol we use for P6. If you watch that video from YouTube from that guy that I say, oh, he's very good, watch that. He will be using this formula to figure out your probability. Please do not use it because you'll be crying if you use this formula. Skip that because you'll be using StatCrunch. So in order for us to use StatCrunch, you use under Stat, Calculator, Binomial. Okay, enter your sample size, enter your P, and then use equal to or less or greater than to do your work. Okay, I'll show it to you how to do it. And then because you got 2 homework due this coming weekend, chapter 5.1 and 5.2. Okay, I will do a little bit of that. And then on 5.2, and then we'll talk about, then you guys, it's not that tough actually. Where is my work here? So I'm going to open up my chapter 5.2 assessment, and then I'll do a quick few minutes of this. So this one is a bit more homework here. So let's say if you read this, based on a survey, assume that 31% fly drones to the repurchase. Suppose that we want to figure out the probability that when 5 consumers randomly selected, 3 of them doesn't like comfortable with the rhizome. What is N in this case? So if you read this, what is N in this case, which is the number of trials? Anyone? Don't forget, it's a nice whole number.
Is it 5?
Yep, 5. So we pick 5 people. So that is your number of try. And what is X in this case? X is the one that we need to figure out. Out of these 5 people, how many people you want to figure out that is comfortable with the drone delivery?
3.
3. So this 3 is your X. What is the probability of success P? That is usually given us in percent. And this case is 31%. And don't put 31, change it to decimal, 0.31. If 31% is success, can someone tell me what is the failure in this case?
69.
69, so it's 0.69. So this is how you figure this one out. It's not that difficult, so make sure. And this is the first thing you know. If you mess up this, you mess up NXP and everything. So make sure you know what.
Yeah, sorry, I have a question. I really don't know how we got the value 5 and 3.
It's right here.
Okay.
Suppose that we want, you have to read.
Oh.
5 consumer, and then there's exactly 3. See that?
Okay. Okay.
So yeah, don't just look at numbers. You have to read. So let me go to a few. Let's do the 0 plus is here. I'm going to go to a probability that you can just reach. Okay, this one. So you want to find. So you got N is 9, and then you have to find success is 0.3. You have to find fewer than 4. Fewer than 4 is less than 4. So how do you do this in your StatCrunch? So so you open your StatCrunch. So you go to stats, calculators. Remember last time we go to custom, but this time you go to binomial. Okay, and then they will ask you for N. So the N in this case, if you read the N, what's the N? The N in this case is 9 trials. And the P in this case is 0.3 is in the question. And you are looking for less than 4 because fewer means less. So less than 4. Okay, we're looking for less than 4. You hit compute, this number is your answer. So in 4 decimal place is 0.729 something. So your answer is 0.7297. So again, when you guys look at the questions on the video, they give you that icky formula, skip it. This is how you do it. It's very easy. Can someone tell me, read this question, tell me what is your N is? Read this question, and what is your N in this case?
7.
7. And what is P in this case? 7 is here, that's why 7 adults are picked. So how do we know N is how many people we pick randomly? That's how we figure out. What is P in this case? 0.45. 0.45, 45% here. Okay. Exactly 3. Exactly, what symbol we use for exactly? Less than, greater than, or equal to?
Equal to.
Equal to, and then you put 3. Because it said exactly 3. And you hit compute, and that is your answer here. 0.2918. You guys okay here?
Yeah.
So this is, again, this is very simple, not too difficult. I really want you guys to try this. It's not too difficult. Again, do not use the formula. Okay, this is a formula. Don't use StatCrunch because it's very simple. You can tell, right? It's just very simple. So so your homework for this weekend, for tonight will be 3.3. And then homework for tomorrow is that chapter 3 special ones, because it is going to be in your test, in your midterm. So make sure you know how to do that. And then homework for next week will be chapter 5.1 and 5.2. And we will do a little bit left on 5.2 and any questions for next week in the Zoom session. So I'm going to stop sharing and stop recording here. Anyone has any questions?